mean, how does it work? I mean, he's got.
Hey, Clay, what are you working on here?
Oh, hey, Alan. I like to figure things out. So I was just really looking at the other day. I mean, how does Santa really visit all the houses in 24 hours with children? I mean, he leaves here from the North Pole and he's got to go all these different continents. I mean, he even got to get down here to Antarctica. I mean, I don't know. You think it can be figured out mathematically?
Well, you know who this sounds like it's a job for?
Who?
The
Acme math guys.
All righty.
Right. Well, all right, let's erase this.
Okay.
So the other day, through my Google researching,
Okay.
I looked up and it said that there are actually 2.3 billion living structures in the world.
Okay.
Houses. We'll just say houses.
Okay.
And there was 1.9 billion children. Let's say houses here. And there's children. And they said that every household has an average of 3 to 4 children per household.
Okay, well, let's try to make this math a little bit easier for us to do in our head, and let's just call this 2 billion.
All right, 2. We'll just keep it down. All right.
And because 2 billion, 20 divided by, so let's just say 4 children.
All right, maximize it.
Yeah.
All right, so we've got 2 billion divided by 4. All right. Well, that works out to be quick math of what? 500 million.
500 million living structures that he
has
will need to
children.
visit.
Yeah. Okay. So Santa has to visit 500 million houses.
Okay.
On Christmas Eve.
Now, let's see. Santa's no dummy. He's going to try to maximize the amount of dark time he's got.
Okay.
So he's going to sit here and he's going to travel east to west.
All right, so he's going to travel east to west.
Yeah,
That's
and
not very good.
that's
east to west.
that's going to give him about 35 hours to do this job.
Okay, so he's going to catch a little bit more darkness as we roll.
Yeah,
All right?
he's going to catch
So
a little bit more darkness.
35 hours
Okay, and
to hit 500 million houses.
Yeah. So we've got, let's think about it. That's 3,600 seconds per hour. So he's got 126,000 seconds with which to do this trip.
All right, so if we did that, so we come over here, so we'll just stay here. So 500 million houses, and that's 126,000 divided by, well, that works out to be
3,968
houses per second. Okay.
Wow. Okay, so
All
if
right,
we take the
that's
if
moving.
If we want to know how much time he can spend in a house, we can take the reciprocal of that.
Okay,
and
so the reciprocal, I'm going to move up here. So 1
Okay.
over 3968
is going to be 0.00025, which would be 2.5. Yeah, 2.5 times 10 to the negative 4.
2.5 times 10 to the negative 4 for you scientific.
That would be seconds per house.
Seconds per house. What kind of speed is that? I mean, how can we wrap our minds around that speed?
Well, if you consider a person blinking their eye.
Okay, all right, so an eye blink.
An eye blink would be 1/10 of a second.
How do you know this kind of stuff?
Because that's what we do. We read books, we drink coffee.
Okay, we just know things.
We just know things.
Drink coffee and read books.
And
all right, so you're saying 1/10 of a second, which that looks like that. Okay, so a 10th of a second. All right.
So based on the arithmetic, if you take this and divide by this, he's visiting 400 houses.
So divided by that.
Yeah.
All right.
He's visiting 400 houses per blink of an eye.
Per blink, 400 houses per blink. That's fast.
That's fast.
Is that as fast as you fell off the roof last month?
It's getting close. It's getting close. But something that's a little bit faster than even this would be a hummingbird. Hummingbird's wings.
Okay. All right. Hummingbird wings. So we're just gonna say hummingbird wings. All right.
And they can do 80 flaps per second.
Did you read that too?
I read that too.
Okay. All right. So 80 flaps.
Mm-hmm. You almost took off there. 80
flaps per second. All right. 80 flaps per second.
Okay, so that would be 0.0125 seconds per flap.
All right, so we flip this again.
Yeah.
Yeah. All right, and you said that's
0.0125.
125. So 125 to
10 thousandths.
10 thousandths
Yeah.
of a second.
Yeah.
Whew, that's
Per
fast.
flat.
And we've seen, buddy, we've seen pictures of cameras.
Yeah, so obviously a camera's shutter speed is even faster than this.
Okay. You know, Brianna has a Canon EOS camera. And I read when we was getting it that they come standard with a shutter speed. So let's talk about shutter speeds real quick.
Okay.
A shutter speed of 1/4000th. All right.
So the standard EOS camera, well, if you do this arithmetic, that's going to be...
Wait a minute. Is this number here, let's say quick math.
0.025, which...
That is...
Looky there.
Looky there. So this number here is the same amount as this number here.
As the standard camera shutter speed.
So that means you can...
You couldn't get a picture of Santa in there.
You can't, because the speed would have to be the exact same.
Is this the fastest camera shutter speed that's available?
Oh, I don't think so. You know, they got them high-speed sport cameras and all that and everything. And I think I read somewhere where Canon does offer an upgrade to where you can get a shutter speed of 1/8000. And that's moving.
Well, so if this is the shutter speed here, then if someone rigged up a system kind of like Barney Fife did to catch the robber coming in,
the electricity guy, yeah, I remember that episode.
Well, if you think about that, then he could actually get two pictures,
two pics of Santa,
while in a house.
So two pics of Santa at a house.
So our challenge to you viewers at home is for you to rig up your camera for this Christmas Eve and capture Santa. And please send all pictures to us via the link down below. And
is there going to be a link?
Probably not. But anyway.
You lost your whole train of thought here because of that. Yeah. Two pics, challenge, household.
Yeah. You know, you can't make this stuff up.
No, but you know what? We can.
Exactly.
And you know what have we learned today? That basically Santa is visiting 400 houses every time you blink your eye. That's pretty cool. So,
it's kind of like what Wile E. Coyote said.
Acme Math Guys.
Genius. I'm Alan.
And I'm Clay, and we are wishing you a very
mathematical
Merry Christmas. Merry Christmas, everybody. Hope you enjoyed that.